Welcome to Train Signal. I'm Mel Haynes, and you're watching the Advanced SQL Server 2008 Database Administration Training. Wow, what a mouthful, and there's more. Because in this video, we're focusing on indexes. We'll look at optimizing your SQL searches using a pretty foundational concept, pretty foundational component of database servers in general, and that is indexes. So here's the list of what we're going to look at in this video, starting with just a general high level, what are indexes and where are they at, how does it fly in the SQL Server environment. And that'll include a discussion of clustered, non-clustered, XML, spatial indexes. Then I'll jump into actually doing it. We'll actually create our cluster and our non-clustered indexes, followed by spatial and XML. Now, there's two ways to do most of this. You can do it using the point, click, drag, and drop, which is great, which is fun, which has limitations over using T-SQL. So we'll do a little bit of both, the exposure to both sides of that equation. Then we'll look at, when do you need to blow away an index? When do you need to rebuild an index, and how do you do it? So we'll look at rebuilding and dropping indexes. There are other index options such as filtered. We'll look at that. What is a filtered index? We'll look at indexed views. So everything before that is focusing on indexes on tables. But indexes aren't limited to tables only. You can have an index view. We'll look at that and what are the ramifications and benefits there. And then last but not least, we'll look at index performance, and we'll get into some of the different things you need to watch out for when working for indexes. Now, I'll be mentioning some performance things throughout the video, but we'll wrap it up toward the end with a general summary of some of that and a few other points I didn't cover before, as well as we'll get into the Database Engine Tuning Advisor toward the end as it pertains to indexes. Now, we'll get into the Database Engine Tuning Advisor in other videos where we focus on SQL Server performance, but I do want to pull it in at least to focus on the area of indexes in this video. Now, the bottom line with indexes while we're on this overview slide is indexes help you get to your data more quickly. Bottom line, that's what it's all about. So why do you have an XML versus a spatial versus a full text index? It all boils down to what are you storing in your database. If you're just storing rows of data that have, first names and customer numbers and things of that nature, then you're typically looking at clustered, non-clustered, and filtered indexes. Pretty straightforward, pretty simple, hasn't changed a whole lot in recent years. Filtered just gives you a chance to look at and build indexes upon a subset of the data as opposed to all of it. Let's say there's certain records that you tend to query far more often than others. Say you query the information over the last 6 months versus the last 10 years, but it's all in the same table. You might choose to build an index over that subset of the data, so we'll talk about that kind of a thing. But then SQL Server 2008 allows you to store information in an XML data type. So we're storing actual XML, extensible markup language. We're storing it directly in our database. So we need to be able to find things, once again, quickly and easily within our XML. So we create an XML index. What does that mean? How is it different? We'll talk about that. Spatial, we are storing far more graphical information now in our databases. How do we find things quickly in that? What does it mean to create an index against that? And then, like I said, the last one there, full text, you want to be able to just create a database of tons and tons of text, right? You've got a database that has the entire works of Mark Twain, and you want to be able to quickly and easily find every use of a certain word within those works. It's a full text search, full text indexing that allows you to do that. But it is a bit of a science in of itself and uses some slightly different technology, so we'll separate that one out. So let's jump in looking at clustered indexes. Some of the unique things about clustered indexes, first of all, you can only have one clustered index per table, and here's why. When you create a clustered index against a table on, let's say, last name or social security number or phone number, the data in the table is reordered based on that information. So if you create a clustered index against last name, SQL Server reorders the data in the table based on last name. If you then create a clustered index based on employee number or customer number, it reorders the information based on that value. So as a result, you can only have, obviously, one clustered index on a table because you're actually physically changing the structure of the table. Another thing to note, and I got this diagram from Microsoft, I thought I'd throw it up here at you, but if you were to look at the internal structure of a clustered index, a lot of this is more of a logical representation than it is a physical, but if you were to look at the physical layout of a clustered index, the last leaf of the structure, without getting into B trees and what a leaf is, but the last element of that structure that you're perusing to find data would actually contain the data. So a term you may hear is the last leaf of a clustered index is the actual data. The structure, the clustered index, in a sense includes the data, in a sense, not necessarily physically. All right? As opposed to with a non-clustered index, it actually points to the data. We'll develop that concept a little bit more going forward. But here, let's look at this. Some rules for clustered indexes, as I said before, only one per table for obvious reasons. You reorder the data based on what fields are used in that clustered index. Second, the data is ordered. Third, it provides excellent searching ability, obviously, because that is what an index does. It allows you to quickly find and retrieve information. You don't have to do table scans through the information, but using the key value, you can do one or two, or usually just far fewer comparisons to jump directly to the information of interest. Now, there are some downsides to that. Before we get to the last bullet point, though, there's one more in here I want to touch on. They are required by some other indices. I want to mention that as well. So for example, when we get into XML index and other types of indexes, they actually require you to have a clustered index. When you create a table in SQL Server, when you identify a primary key as part of the creating a new table, SQL Server automatically assumes you want a clustered index against that column. All right? So just some things to know. It's kind of almost a default that can happen with SQL Server. But the last thing on the list, it can be high maintenance, however. Because all the data is reordered based on the contents of a field, if you're doing primarily lookups against the data, it's great. You go to it, you find it, you retrieve it. But if you're constantly updating or adding or deleting information, deleting probably isn't quite as bad because the order of the rest of the records doesn't have to necessarily change. But if you're inserting or updating data, now the order is changing because you're inserting things in the middle of your structure. So everything has to be shifted around. So you can actually have high maintenance costs when you have clustered indexes against tables that are being frequently changed. Talking about a non-clustered index, what's the difference? Non-clustered, you don't reorder the data. That's the biggie. It points to the information in place. So you've got this tree-like structure, and I didn't really develop the structure, but it's probably far more information than you'll need on a day-to-day basis. But clustered, non-clustered indexes all use a basic computer science concept known as a B tree. It's a tree structure where you've got nodes that point to other nodes that eventually point to other nodes, and in some cases, such as back here, in your cluster, they actually eventually point to the data because we said the data is just part of the structure. With a non-clustered, the data isn't really part of the structure. The structure lives independent of the data, separate from it, and then it points to the data. So you have these first two gray boxes refer to my, as it says here, my non-clustered index, and then this last section down here, and it says here heaped or clustered index. Here's the actual data here. And the difference is kind of a break in between, because with the non-clustered, it points to the data. That has some interesting ramifications. First, you can have lots of non-clustered indexes because no particular non-clustered index forces any requirements on another non-clustered index. It can all be pointing to the same record from different places. Now, the limit is a little higher. There's up to 249 per table. So SQL still implements or imposes some limits on you, but it's nowhere near as strict as with a clustered. As I said before, it uses pointers, but here's a biggie. It's affected by changes to clustered indexes. Because remember, a clustered index reorders the data. If you create a clustered index on last name, then create another one later on based on social security number, you've changed the physical order of the data. So now your non-clustered index has to be updated to point to the data in its new location. So as I mentioned before, you can actually end up with a performance hit, a significant performance hit, as a result of indexes if you're not using them carefully and wisely. Of course, when you're talking SQL Server, you're talking a lot more than just text data. One other format you're going to commonly encounter, these days at least, is XML. So you'll see things that look like this. XML tags with sub-elements inside, and you'll want to be able to easily and quickly find information within an XML blob, as it's called. So SQL Server supports XML indexes. Some things we want to focus on when we're looking at XML indexes are the types. There's two main categories. You have your primary XML index, and then you can have secondary XML indexes. And that is singular and plural on purpose. You will have one primary XML index, must be created first, and then you can create secondary XML indexes later. Your primary XML index will do something called shred your XML, basically pull the information of interest out of that XML, as opposed to your secondary XML indexes will just use that information that's already there. It says there, a shredded and persistent representation of XML blobs is a quote. I wanted to put double quotes around that, but it just didn't format nicely, so I took it off. But that is what you get with a primary XML index. A shredded, persistent, and that's a key word, representation of your XML blobs. Because if it's persistent, that means if the underlying structure is changing, such as you have created or destroyed a clustered, or you want to destroy a clustered index, you'll have to remove the XML index, destroy the clustered index, recreate the clustered, then recreate the XML, right? If you're inserting, deleting information, all those things will impact the underlying persisted representation. So you want to be aware of that, because once again, indexes are great ways to speed up the retrieval of information. If the data is changing regularly, rapidly, you might want to revisit how to use indexes, because you will see a performance hit. Looking at spatial indexes, pretty cool stuff. Once again, with SQL Server 2008, you're not just tracking, textual data anymore. We're tracking all kinds of stuff, including, hopefully, a little bit of graphical stuff, geometric stuff. So you can use your database to store information as far as, where a client's located, what's the layout of their property, and things of that nature, which can be really cool and really powerful stuff. So if you've got data of that nature, guess what? You have to be able to index it so you can find things quickly. That's where spatial indexes come into play. Now, some rules to follow. Can be created only on a column of type geometry or geography, which makes total sense. That's what you're creating, right? And SQL, if you're using the SSMS, the Management Studio, it will kind of guide you there. It won't even let you create an index using a column that's not geometric or graphic. Tables must have a primary key, but your table should have a primary key anyway, but just so you know, it will enforce that rule. You can create a few of those, unlike clustered indexes. With spatial, you can do up to 249 on a table. One limitation, however, with spatial indexes, now we haven't gotten into views yet, but seeing how this is a more advanced SQL class, you should be familiar with the basic idea of a view. So I'll throw this in there just so you can have it all in one place, and that is you cannot create spatial indexes on indexed views. Okay, so that's one of the little limitations. But here, let's jump over to my server and let's go ahead and add some indexes to our database. So let's roll. I'm going to go ahead and bring up SQL Server. I'm currently logged in as MDM. Okay. Hit the drop down. I want the local database engine. First time through, it might ask you for that. Windows authentication, so it's not giving me a chance to enter a different username. It's using the same thing I'm running under for Windows. Click connect. Log on fails. So what went wrong? We've not added MDM specifically to this SQL box. So I need to cancel out of this and move over to an account that's already part of SQL, one of the accounts I used perhaps when I was doing the installation, and use that account to add my other users. I'm going to switch my Windows login over to, and I already have my administrator logged in. Just going to switch over here. And now logged in as administrator, go into SQL. Click connect again. Give it a few seconds to wake up. Go ahead and maximize it. Go to security, go to log, ends, and notice I have SA and I have administrator and a few other system accounts. So I need to add a new login, and I'm going to grab that from my domain. Click search. Current location is looking at the local server. That's not where I'm going to get my domain information, so clicking on locations, since I'm in a domain, it prompts me for a user account that has rights to access the Active Directory information on the domain server. Administrator, spelled with all the proper I's. And my password. Now I can see it. There's my domain. Grab that. Click on Advanced, Find Now, and now it's pulling a list from my domain, melsdomain.local, right? And we're going to add, there's my MDM, and ultimately we're going to put MDM in a user, in a group. I don't have the group out here yet. We're going to add that later. But ultimately I'm going to create a SQL admin group, and MDM should be a member of that. Because generally you want to add groups and avoid adding and removing users, but I don't have that there yet. We're going to postpone some of that till we actually get to security stuff. So for now, just add that user. Still using Windows authentication, server roles. I'm going to make him a sysadmin, setup admin, server admin, security admin. He's just admin demigod, which is probably more than I will always want to have. But for now, I want to make sure that I can do everything under that account and not have to come back to my administrator account. So I click OK. And we'll do all this again in the security video, but I just want to get you up and running so we can do the other stuff, such as simply creating indexes. So that's done. Close it out. Switch users again. Go back to my MDM. And we're in. Now log into SQL again. Pick a server. A local database engine. Only should have to do that once. It remembers it. Click connect, and I'm in. This time he's in, he's golden, he can see the databases, he's live. So here's what I want to do. We want to create a database to play around with first of all. I have a script out there. We're going to run file, open, file, and on the C drive I have my Veronica's database. Now just kind of note that is in a folder off the C drive in a subfolder, course files on C, Veronica's, right? So the path in the scripts is hard-coded. So you do want to make sure you create the exact same file structure. It's on your CD. You should be able to copy it right off your CD that way. Just want to point that out. That is important. But I'll go ahead and select the Create Veronica DB. And I could run this to create my Veronica's database. We want to make a few changes to it though. We want to create indexes of various types. And I'm going to add to my flowers table, a comma here, and I'm going to add a field. Performance as XML. Make sure you add a comma there at the line before. And for customers, I was thinking we could throw one on there as well. Let's say we want to do very smart marketing to our customers so that we can say, hey, based on the layout of your property, the positioning of your house, and the available space around it, here are some suggested purchases based on, say, if you're facing north, you have a two-story house, such as in my case, there's no light in front of my house, have to pick stuff that needs minimal amount of light. As opposed to the back of my house, I want stuff that does well in full sun all day because I have a southern exposure. So all that kind of creative marketing, we want to try and incorporate that into our sales pitch, right? So I'm going to put some mapping information or an aerial view. And this would be a geographic information. Aerial view, and it's a geographic view. So I've had this script laying around for a while. We're going to make those two changes. Now, one other thing though about this script, I've used the script before. We're going to use it again later. But for now, we're going to ignore some portions of it. Down here below, I actually populate it with data that I have out there in some CSV files. We're not going to populate it with data at this point, simply because my data doesn't match those fields I just added. So I'll get errors when I try and populate it. But we can go ahead and create the database, just not populate it yet. So I'm going to highlight from here up, click execute, so it only gives me that portion of it. Be patient. I get one little error / warning message saying it cannot drop the database because it doesn't exist. That is true. But later on, if we run it again, we won't get that error message because it exists. Now if I expand here, right click, refresh, voila, there's my Veronica's database with tables, my customers table, columns in my customers table. I have a primary key field, I have my aerial view, way cool. If I go to my flowers, same thing, everything plus what I added, columns. There's my performance as XML, way cool. All right. Now I put those there because in order to do some of my index types, as in spatial or XML, I have to have columns of those data types. So now let's start looking at indexes. Go to indexes. There we go. Right click, and there's my new index option. Now before I do that, let me expand this. PK customers cluster. There's already a clustered index on this table. If I look at my script here that I used to create it, let's go scroll through there right quick. Flowers. Give me screen real estate. I can't see here. Get rid of you too. Now there's flowers. There's customers. And right in here I'm telling it to create a clustered primary key with a clustered index. Right through here. All right? But I did want to point out something. I'm going to do a little side tangent and then we're going to come back to this. I just wanted to point something out. I'm just going to create a dummy table. Not to steal some of that screen real estate back. Call this table, let's call it test, tester, maybe even testy, right? And I'm going to give it a feel. I'll call it ID number, ID num. Give it a data type of, I want a numeric, I want an int. No nulls, right click, set it as primary, right? And that's really all I need, but I'll just put something else on here. Some more data. Real descriptive stuff, right? You know exactly what's in there. And just for readability, for those of you who would get lost in all the letters, such as myself, add that in. That default data type is good enough for what I want to do. Table name is good. Click Save. And there's my temporary table with my columns, right? Primary key and otherwise. Going down to the index folder, notice there is a clustered index already on this table. So SQL Server by default will create a clustered index against your primary key. So it's saying up front, well, if you took the time to make this field your primary key, let's order the data based on that index, based on that key, and create an index, a clustered index. Okay, so I already have a clustered index. I wanted to point that out simply because some of the other things we're going to do require you to have a clustered index. All right, so I'll get rid of some of this stuff, clean up my screen a little bit. I don't need that anymore. You can blow that away. Right, kind of clean things up, and I'm down to just the Veronicas. Right, so now what we want to do is go ahead and start looking at some of these different types of indexes. Let's go into tables, going into customers, and I already have a clustered index, but let's say we didn't. If I right click on indexes, go to new index, brings up an interface where I can create an index. It defaults to non-clustered. I already have a clustered index. If I told it clustered, it says, hey, you already got one. Do you want to blow that away? Because you can only have one clustered index, because remember, clustered index determines the actual order that the data is physically added to the table. It actually maintains the data in the order that you, for the data that the clustered key is using. So if you're doing a last name clustered index against a last name field, it's going to keep the information in the table ordered by last name, or if it's on primary key, it'll keep the data in the table based on that primary key field. So I don't want to blow that away. I'll leave that alone. But I can add a non-clustered on my other data fields. So I'll just say, let's say that other field had been last name, which would have been a better example to throw a temporary one out there. But index name, I'll call it name. Click Add. Gives me a list of all the fields. That's right, we did switch back to customers, so it's there for me. It gives me a list of all the fields that I can choose from. Notice area view is grayed out. I can't create a non-clustered index against geographic data. So it doesn't even let me try that one, right? But if I need to do periodic searches against last name, I can pick last name or multiple fields, last name and first name. Click OK. Determine which one is primary, so I can move last name up. Right? So I want the index to be last name, first name sort or access. Click OK, and I've got a new non-clustered index. The benefit there, performance should be a little improved, and we'll look at more on what a little improved means later when we get to measuring performance. And let's look at a few others. If I right-click on indexes again, go to New Index. This time I'm going to go for spatial. Give it a name. Call it map data. Because we've got all of their houses scanned and in our database, right? Click Add. Comes back and asks me what column. Notice everything else is grayed out now except aerial view. It's the only option I have. Click OK. Throws it in there. Click OK. I didn't change a field. Here, let's go over here. Spatial options. It defaulted to geometry. It did not default to geographic. I'm going to change that. Okay. Now click OK. Because we are doing geographic information. I specifically said it was geography was the data type. So we now have a clustered, a non-clustered, and a spatial or geographic index on my customers table. Let's do one more. This time we're going to do it against the flowers table. I'm going to go to my indexes again. Notice all I have is my clustered. I right click, new index. I'm going specifically to primary XML. And once again, what is primary XML versus secondary or triary? Your primary XML index is, first of all, the first XML index created has to be primary. After that, you can create secondaries. And the primary XML index will actually cause the XML to be shredded, which is just a fancy term for we're going to clean out all the XML tags and grab the information and reorder it in a format that's easier for SQL Server to manage in a relational structure. All right? So I'm going to give this a name, and this is performance index. Click Add, and you know this song and dance now, right? It's smart enough to say, hey, only one field in the whole list qualifies. Click OK. And I've managed to add an XML index to my flowers table. So let's say, why would I even want to have that in this case? What is XML data? It's really relational data that's not in any industry-specific format. It's more generic in its structure. And let's say I get regular updates of something dynamic about these products that we're selling, such as weather conditions are constantly affecting flower quality, flower price, or things of that nature. We can get